Um, Hi, thanks for coming in this early in the morning after yesterday's tram club. Who here went to the tram yesterday? Surprisingly, yeah, not a lot of people. If you did go, you probably aren't here. My name is Savvas. I'm a senior software engineer at Shazam. These are my Twitter handles and links. And I'm here to talk about a problem that I'm sure many of you have faced and how we solved it at Shazam. Who here has had to implement analytics in their application? Page views, events, okay, most people. Who had to implement ads in their app? Yep, unfortunately, we have to implement ads in our apps if we want to monetize. Now, out of those people that have implemented ads in their app, how many people have had to change ad providers after they've already released their app in the App Store and the Google Play Store? Okay, surprisingly few people. Actually, that's good. You guys are lucky. It's not the easiest thing to do if you don't do it properly. We had to change our ad providers, and it took us less than a day to do so. And I'm going to talk about a bit about how we did that and how you can apply that to your own project. Well, as engineers, we love reinventing the wheel, so that's what we did. We reinvented the wheel. This talk is the first talk that I've given about this library that we've developed after deciding to change the name of the library. This happened literally 2 days ago. So all the examples I'm about to show you mention aspects as an aspect-oriented programming. Who here has heard about aspect-oriented programming? A few people. Oh, okay, more than I expected. People tend to be afraid of aspect-oriented programming. They think it's this massive monolithic thing that's it brings like Spring and things like that into mind. It actually, after discussions with some friends, after presenting this at a local London Android group, it became clear that what we've actually built is more akin to traits, like Groovy and Scala have. Are people aware of what a trait is? Okay, fewer hands. Basically, a trait is sort of like a cheat to allow multiple inheritance without having the bad things that multiple inheritance carries with it. So you can apply behavior to an object without modifying its code by inheriting that behavior, but you don't run into the diamond problem that most people do when you, for languages that do allow multiple inheritance, such as C++, I think, does. So basically, who had to extend a fragment or an activity only to later find that they need to extend another fragment or another activity at the same time to get some other behavior that they needed? A couple of people. This used to be a big problem in the old days of Android. When every third-party library that you implemented began with extend our blah, blah, blah activity, and you get that behavior. Thankfully, people have learned their lesson. They don't do this anymore, at least not a lot. But you can still run into this problem internally in your own application. For instance, you have some behavior that you want to spread across multiple activities or fragments. You're tempted to put it in a base activity or base fragment. That's good, it works. Then you have some other piece of functionality. You do that in that base fragment as well. And then, of course, you run into this problem of you want the first behavior without wanting the second, or vice versa. So you can't really solve that problem because, again, the diamond problem. So you need some system. Since Java doesn't allow traits, you need a library that does it for you. Now, I said that this library's purpose is to prevent you from having to extend other activities. But in order for this to work and get around Android's and Java's problems, we have to extend a custom activity, unfortunately. But hopefully, this will be the last activity you will ever have to extend. The library, it's on GitHub. It's open source. It still has the old name, as you can see. It's called Android Aspects. I will be changing this to Android Traits very soon, but there will be a redirect link, so please check it out. I will now show you an example, a demo, basically, of how this works and what you can achieve with it. Yes, this is a live coding session, so let's hope nothing goes really bad. Let me deploy this app. It's a very simple app. It doesn't do anything interesting. It's literally a screen that has a button that launches another screen. And there you go. There you go. We have an activity. I press the button, launches the second activity. Nothing fancy. Now, I'd like to show you, this is the activity. It's very simple stuff. It just sets a content view with a button, finds the button, says a click listener starts the new activity. Nothing fancy there. But you will notice this line that says aspects. This will be changed to traits. And it takes that annotation, takes a list of classes that implement that interface, aspect. Again, will be changed to trait. What this does is basically says, I want this activity to delegate all the callbacks of that activity to this aspect here. I will open this aspect. By the way, can people see the font? Should I change it? It's okay, I got a thumbs up. So this aspect is very simple. If I will open it, you'll see that basically I'm getting the same callbacks as an activity does. Here I've already overwritten the onStart and onStop. They're slightly different, as in you get the activity passed to you as a parameter, because remember, you're no longer extending from that activity. This, by the way, is the thing that solves the diamond problem, because you don't have access to private members of that activity, and protected, sorry. So when you extend an activity, you can change its behavior from its child. Well, that's the same true for any Java object, but here you don't have access to that. You only have access to the public interface of that activity. And if you, let's say in this case, we override the onStart, if you have two aspects that override that callback, they don't step on each other's toes. They get executed sequentially. This is a very simple piece of code. It literally just gets the current timestamp, and in onStop it logs that the activity has stopped and that the page view took how many milliseconds it took. That user journey, if you want to call it, that I just showed you before with the app, generated these logs. If I can actually open the log cut here. Okay, so not that easy to see, but I will highlight the lines that are important here. These two lines. It says that the activity stopped and the page view lasted 4.3 seconds and 2.8 seconds. Now that's very cool. We've already, with minimal amount of code, just one line for activity without changing its internals, we've provided some behavior to this class. But it's a bit useless because this is a static class. It doesn't really do anything. There's no context around what page was viewed. Like you have, like an activity was shown. Cool, which one? We care about these things. So now I'll show you how you can basically create custom annotations that allow you to statically configure these traits, as we call them from now on. Let me check out the next commit. There you go. So here you'll notice I now have a custom annotation. It's not that aspects one, which will be changed to traits. It's called with page view, and it has a parameter with the name of the page. Now, for those unfamiliar with how annotations work, an annotation is kind of like an interface. It's annotated with an @ interface. It allows you to define a list of methods, which are basically properties, but you only have a very limited amount of types you can return for those methods. In this case, we have a string. There's no default parameter. There's no default value. And basically what this means is that whenever you use the with page view annotation, you have to provide a string for defining the name of that page. Traits, I need to start calling them traits, are inherited. So if you have an annotation that is annotated with a trait, and you use that custom annotation in a class, that class will inherit that trait as well. So this annotation here is annotated with the named page view trait, which, like previously, does the same thing. It gets the time of the onStart, prints out the duration in onStop, but it also, in onCreate, tries to pull the attributes for the page view from the activity that it's annotated with. As you can see, we get this activity as a parameter. We pass it to a method that is a very simple method. We get the annotations from that object. We try to find the with page view annotation, and from that, we retrieve the page name. And of course, we log it out. And the second activity, by the way, is similarly annotated with the same thing, but with a different name. Now, if I launch this, let's see. Start a new activity, wait a few seconds, then leave the app. You will now notice that the page views have a name. It says activity main stopped, page view lasted 1.9 seconds, activity second stopped, page view lasted 2.9 seconds. Now that's cool. It's a step up from what we had before, but there's still a problem because most of your app is not statically configured. You have very few pages, hopefully, in your app that are basically a static piece of content that you don't need any contextual information about. Maybe your main launching screen has a static configuration. You always know you're displaying the same thing to your user. But unless your entire app is defined beforehand, you always know what you're displaying to the user. this will not be very useful in those cases where you do display dynamic content. Like in our case, I work for Shazam, we do music recognition. So when we have a page view of the result of a track, we'd like to know what that track was so we can monitor these things. So now I'm going to show you how we do dynamic configuration of these traits. I'm going to skip a commit. I will explain in a bit why that commit exists. There you go. You can ignore that second parameter. That was basically the last commit that I had that I skipped. This introduced some strategies into the mix. They're not really that important. They're still static configuration. You can see the main activity is still implemented the same way, the page view. There's nothing different about it, apart from that strategy thing. The other difference is that when we launch the second activity, we now give it some data. In this case, I'm generating a random string using a UUID, but in the real world example, you would pass in the ID of a track, in our case, the name of a venue, whatever your app displays. It passes it as an intent extra here for simplifying things. Now, the second activity is where it gets interesting. Apart from the annotation with the page view, the second activity implements an interface. This interface, page view configurator, is a generic interface, as you can see, and it takes a type, which is now used in the page view annotation. I previously had a string as the name of the page view. I've now introduced a model, an object model for it. It's an interface, it's called page. It provides two things for you. It expects a string and a list of, and a map of string to string for dynamic configuration of parameters for that page view. And that configurator takes that as a generic type and provides a method to the activity, in this case, configure page with that object. Now, before I continue here, I need to explain some things. Like the whole point of this library is to allow, first of all, to take those cross-cutting concerns such as advertising and analytics and move them out into reusable objects so you don't have to keep writing the same code over and over again, but also to separate them from your business logic. Now, the whole point of ads is to generate money. They're not part of your app. Like no user downloads your app to watch ads. That's not the main purpose of your app. The same thing goes for analytics. Like no one really wants to be tracked. But you know, that's the reality of things. All the web pages, all the websites do it, all the apps do it. That's why you shouldn't actually move that behavior into your business logic. Now, I'm already modifying an activity here to configure that page view. So I'm not actually doing something different to what I've already mentioned, because in our code, at least, we follow an MVP pattern. I hope you guys know what an MVP pattern is. Hands, maybe? Okay, many people, that's good. Things changed a few years ago. Most people in Android conferences, well, it's not an Android conference, but in talks about Android didn't really follow any architectural patterns. That's very good. So with MVP, our business logic lives in a presenter object. Here, of course, it's a very trivial example. I haven't created one. But the view, the activity in this case, is the view. It's a very dumb object that simply reacts to events from the system, delegates to a presenter, says, oh, I've started, start presenting. The presenter then does things and then notifies the activity to present things to the user, as in display this name of the track somewhere, and the view knows how to do that. There's no really ifs, there's no cyclomatic complexity in the activity. So in that case, in this sense, the analytics and the page view is view-related logic, because it's very tied to how the information you want is displayed to the user. So it has nothing to do with your business logic, it has everything to do with your view logic. So that's why we actually do this here. We override this method, getting back to this example, and we provide to that page object an extra parameter, and that's a track ID in this case, which we got from the first activity. Excuse me a moment. Now the trait itself, like before, like I said, I've introduced some strategies here to allow you to configure when the page view takes place. It either takes place in between on start and on stop, or on resume and on pause, to allow for different behaviors. That's not really that important. Like before, we pull the attributes out of the object to get the name. In this case, we get the page. And we have an object that when it retrieves those annotations, let me just find this here, annotated page retriever. This object is the thing that basically now goes and finds the page object from the activity in this case. I've extracted it for simplicity. Yes, it also checks if the annotated object implements that interface that we set page view configurator, and it will then allow the activity to configure that. That's it, and basically let me open a strategy here to show you how it's actually written out. There you go, the strategy. Start-stop strategy is using a session manager. Now, this also demonstrates the fact that by doing this, you can abstract the behavior of these view-related logic into objects that are pure Java. There's nothing to do with Android. Here, I've already gone through a pure interface by the traits. You can already see there's no Android dependencies there apart from that parameter that is passed. But there's still some, like I said, that parameter. But when those objects delegate to other objects, it allows you to do two things. One, unit test those behaviors. In this case, the session manager can be unit tested because there's no knowledge of Android. Now we've transitioned into the domain of a page view. There's a start page, there's a start session, in this case, stop, names, that sort of thing. There's nothing Android about it. And the other thing that it allows you to do is it allows you to create two traits, one that applies for activities and the other one that applies for fragments, put them both into that custom annotation you had, and reuse that annotation anywhere you want. So that with page view annotation that I've shown you, you can use that as it is on a fragment and on an activity if you add the extra trait to it, and it will work seamlessly. The session manager here is a very simple thing. It does what the trait used to do before. It gets the time, and it uses that object to retrieve the page, like I demonstrated. And from it, it builds a message that says this is what the page view looked like. Let me launch this. Starting the new activity. That now received a random string in it. I will exit the screen. And in the logs, you will now see that the page view has a name as before. It has a duration, and it also has a parameter track ID with that random string. The first page view, which is like a few lines above, is still just a statically configured one. There's no dynamic content to it. The name's main, and the duration was 1.8 seconds. Now, going into ads. Ads are surprisingly similar to page views when you think about them in that sort of manner, into this cross-cutting concern that needs to be applied in some callbacks in your activity. There needs to be some setup, there needs to be some static configuration, some dynamic configuration. I'll show all these things in a bit. This, from now on, is very similar to what I've shown you so far, but I will go through it just to demonstrate how you can reuse this for other things. So, for ads, you usually integrate with a third-party SDK. Now, in this case, I haven't actually done that because for demonstration purposes, it's not really necessary. But what I have done is, and I will demonstrate by launching the app, is create a fake view. It's literally just a red box that after a while turns green, signifying that the ad has loaded, but prints out on that box the information that the ad needs. And I will show you now what that is. So if I launch the new activity here, you will see there's a red box there, now it's green, and there's a string there that says ad ID, and there's a name, second page ad ID. Now for those who haven't worked with ad providers, the way you configure an ad for an individual page is to provide it with a site ID, or a zone ID, some providers call it. It's basically a string or a number, usually, depending on the provider you use, that says basically, I want this group of ads to be targeted for this screen. And if you use the same site ID for different screens, you will get the same kind of ads. They're sort of like a grouping of ads. Now, in most apps, you want a readable name for your screens. Like the websites will do the same thing. So you basically say, my home screen. You name it home. And that maps to a site ID. Or you have details page, and that maps to another site ID. That can come dynamically from your server. That will allow you to configure your ads as needed, or it can come from a static configuration inside the app. How this is done in this case. So let's open the second activity. The main activity hasn't changed. Now there's a different trait here. There's a different custom annotation. It's called with add. It's very similar to the one before. It takes a string, going back to the original static configuration of the page view, it takes a string which signifies the name of that page. In our case, this is called the second page. Now, like before, that has a trait, an add binder, that is so similar to that page view, it's very basically self-explanatory. You pull the add out of the hierarchy. Here, I'm using some convention over configuration. I'm assuming that all the ads share the same ID. It's called RID advert, but that is easily configured. You can actually put that as a parameter into your custom annotation. It doesn't have to be like this. We do this because it's simple. And unless you have more than one ad in your screen, it's a nice convention to have. And then, of course, we retrieve the add ID from a configuration object using the page name which we've pulled out of the annotation, like before. In this case, the configuration is a very simple static map of names to site IDs. But this will usually be a dynamic thing that came down from your server or from something similar. And then you ask the ad to load. The way the ad does it is just simply, literally just posts a delayed message into the main queue to be processed after 1 second to turn the color green. There's nothing fancy about it. And it also prints the site ID so you can see it. This object is reusable, like I said. You can literally just slap that annotation to any aspect, to any activity or fragment. And if there is an ad in that hierarchy, it will find it, configure it properly with the name you defined, and everything will be okay. Now, like before, ads are not static creatures. They need some dynamic configuration because you want to target ads to users. You want to target ads to users not because they're more likely to click on them, which would generate more money for you and your app, but also because if you display ads to users that have nothing to do with what they're looking at, they will probably leave your app. Like in our case, we display music results. We do music mostly. So if our users open a details page and saw the ad for a burger, they would not like that a lot. But if they saw the ad for a new album release, they might think, oh, that's part of the content. There's this music, so it's kind of related. The way that ad providers do that is they allow you to give them a bunch of, basically a map of string to string again, that is contextual information about what you're displaying. So in our case, you might give them artist name, Madonna. Or if you're displaying venues, you could say venue name, the name of the venue. So they can then do, because there's a real-time transaction, real-time auction happening every time you request an ad using the keywords you provided. And I assume you know where I'm going with this. This is exactly the same thing as before. The second screen now implements another interface called the ad configurator. That, again, ads are very view-related logic, pieces of logic. They're not really your business logic, so in that case, they should live in your activity. That makes sense. The method that they receive, the override receives a facade to the ad. It's basically an interface around your SDK. That's an interface, a very simple interface. It only has one method currently. It's called that keyword, but introducing this abstraction would allow you to swap implementations of your ad provider, like I mentioned in the beginning of the talk. Here we give them some keywords. We, again, only give the track ID. But in a more real example, you would give, like I said, the name of your artist or your venue. And the way it's implemented now is that the aspect, trait, is looking for that interface and lets the activity configure it. And the implementation of that is our view now implements that facade, receives those keywords, and just adds them for on the text view to be displayed. To demonstrate, we will launch the app again. This is what it used to look like, and now there will be an extra parameter that automatically comes from the name of the page, basically. If I launch this now, starting a new activity, there you go. There's a track ID, which is a big random string there. And to do that, we didn't have to modify the activity match. And it can be reused. Now, making the example a bit less contrived, a bit more useful, leaving the page views and the ads aside, the other type of analytics you usually have in your ad are user events. Things that the user clicked, how they navigated the app, what are they selecting. So in this example, I've changed the app to display a list of tracks. As you can see, just a list of random tracks They also have a buy button on their on the row, but you can also open the track, and you can see that the name of the track is displayed, and there's also the buy button there. It's a bit more useful. So currently the buy button does nothing. It's just a button here for demonstration purposes, but you want to track how many people click that button. So let's click it. I will click it now, and you'll see that there's in the logs there is an event logged out. It says it's a user event. It has the track ID, what track am I buying, and the type is buy button click. That's cool. You can now track how many people want to buy tracks. You can also track how many which tracks they're buying. How does that work? This is not this has nothing to do with this specific library, but I'll demonstrate this anyway. So the second activity now has a button, a buy button, which has some business logic encapsulated in there, view logic, excuse me. When you bind the button to the data of the track that you're displaying, you can see here there's a bind method. We retrieve the track ID from it. That's a very simple demonstration button. But when you click it, we generate an event using another abstraction that is very useful to have in your app. If you don't do this, go and do this like today. It will save you countless hours of pain when you have to change your event analytics system. Basically, this is an abstraction around the events. We have an object model for it. We have a type for the event. We say it's a user event, and then we have an object that defines the parameters. In this case, we hard-code the event type. It's called buy button click, and the track ID is the dynamic thing that was bound to the button. And of course, apart from that, you would also launch the page to buy the track, but not in this example. So that's cool. That's very useful. But if you'll notice, I've bought the Smells Like Teen Spirit track. If I leave this screen and buy this track from this screen now, I click this button, you will see that the event logged here is exactly the same event. It has the same track ID, it has the same name, there's nothing to differentiate the two. Which might not be a problem for you, but in most cases you want to track user behavior not only in regards to what they're doing, but where they were when they were doing it. So you want to track, is putting the buy button in that list of tracks important to us? Do we generate revenue from it? Should we take it out? Do people click it? Should we move it to the left by 10 pixels? Will that make people click it more? Now, to get that contextual information, you can do two things. Give me a moment. You can infer where the user was by looking at his user journey through your analytics. So you can see the page views that they did. If you're tracking the users individually, you can see which screens they've been on, and you can then see these events in between those page views, and then you can infer, oh, okay, this is in the main screen, this is not in the main screen. The problem with that is that it's very computationally intensive. You have to have a data team that runs these queries for you, and also if you have a gigantic data set, like we do, running those queries may take forever. And you want quick feedback, especially when you make changes. So when your product owner comes and says, listen, we should move that button to the top of the screen, we think it's going to get user engagement. And you do that with an A/B test, and you need to monitor that behavior. You want that the moment it actually goes out. So you can't wait for your data team to crunch the numbers a week afterwards. So what usually happens is your basically business requires you to add that contextual information into that button, a name of the screen, for instance, which can be problematic because now you have to pollute your domain model with the name of the screen that this model is displayed on, which is not nice. So in this case, the button currently is bound to a track object. That track object is part of our model. It lives in pure Java code. It's literally just a bean. It has 2 strings in it. But now I have to pollute this with a screen name or whatever else might be required. It's a slippery slope. You think, oh, it's just a string, I'll just add this. We did that. We used to do that for a long time. And the more requirements come in, the more difficult it is to keep track of. And using your unit test as well, it gets really messy. Every time you have to add something, you have to go and change your unit test. It's a mess. So what we've come up with is a way to receive this contextual information automatically in your events using another trait. And this will demonstrate how traits can work together. So a trait being aware of another trait. Have I checked this out? No, I haven't. So getting back to, well, the second activity in this case, the first one implements that as well because it also has a by button. There's a new annotation here. It's called attach page view to root. Now, what I'm about to show you here, the logic that goes into this trait, could have moved into the page view trait. But the reason we haven't done that, well, I haven't done that in this test, in this example, is first, I need to demonstrate interoperability of traits. And second, you wouldn't want to do that anyway because you don't always need that behavior. So you should separate those out as much as possible. So when you do need this, what this does is effectively looks for the other annotation, the trait that sits behind this. It looks for the page view annotation. From that, it receives the page name, and it uses that to attach a bundle of data into the root of your Android view hierarchy. It basically literally goes and finds the root view. It's always, I can actually show you, it's going to be easier. So opening that, the trait pulls the page, uses the page retriever, which is another example of why introducing that abstraction was helpful here. We can now reuse this between the page view object and this trait. We receive the page, and if we have a page, we can then basically find the root of your hierarchy, Android RID content, it's always there. Find that, build a bundle of parameters with the screen name, using the name we just received from the page. We also have the page you allow, as you can see here, there's a get parameters method. It allows you to also pass all the parameters that come from the page view into this object as well, if you want to. So if you have in your annotation some extra parameters, you can do that as well. Like that track ID that we had and all those things. And then just sets them as a tag. Now this is a method that has existed in Android since the early days. It's called setTag. It exists in all views. There's two flavors of this. One that just takes an object, that literally just takes that object and sticks it as a field somewhere in that instance of the view. And one that takes an ID integer as well, so you can have lots of them. It's more preferable to always use this one because that means that your tag cannot be overwritten by anything else in the system. So we set that object. That lives in memory. There's no downside to this. There's no speed problems. This literally is just a field assignment. It takes no time at all. So that's one side of it. The other side is the event analytics abstraction that we had introduced before. Now has a slightly different syntax. It takes a view as the first parameter of the method call. Everything else is still the same. It takes the event and a parameters object. Now the implementation of this uses a class to go and find that tag that was set in the root. It could go and find that root directly, but in this example, it literally traverses the tree from the object that you gave it, the view that you gave it, all the way back until it finds that object. It does so by doing this. It's a very simple recursive call. Do you have that tag? No. Give me your parent. Is it a view? Yes. Go and find that tag in there, and so on. What this allows you to do is it allows you to have multiple levels of these objects. So you can use that annotation in a fragment. In the fragment's case, it would go, you would have a different trait for that, obviously, but it wouldn't attach that bundle into the root of your view. It would attach it at the root of the fragment's view. So then you can basically say, you know, if my buy button comes from this fragment, it will get the parameters of the fragment. If it doesn't, it will get the parameters of the activity. And all this happens automatically. Many people cringe when they see this method. They feel like this would take a long time to do. This is, the view hierarchy in Android is held in memory. There's no weird, you don't have to traverse XML. There's nothing weird like that. It's literally a linked list. So every time you basically traverse a node, it's like, does your node have this? No, go on node up. So it's a linked list, basically. It's very simple. You still don't want to do this in a tight loop, obviously, but you know, it's not taking a long time to do. It takes that bundle from that object that it found, and then it merges them with the bundle that the user provided in that button. It does so. It's literally a simple map of strings. It just merges the two maps together. So now when I launch the app, not having modified the buy button, apart from just adding this into the first call, I will now buy the button, the track on the main screen, pressed it. I will open the second screen, wait a bit, and then press it again. And now you'll see that the events, that's the first event here, this has a screen name attached to it. It says main. And the second event, similarly, is the same event, but the screen name is now second. This is the only parameter we inherited automatically in this case, but if the page view, like I said, was configured to add the name of the artist, for instance, or whatever else, this would also get them without you having to do anything. That's it for the live demo. Getting back to the presentation. Come on. Cool. So, traits. Traits are very useful. They basically allow you to get the cross-cutting concerns in your app, identify them, and reuse them very easily without you having to modify a lot of code. But they can be dangerous as well, because like any tool, if you have it, you think, oh, this is amazing, I can do everything like that. There is a separation there, because navigating that hierarchy of classes can be quite tricky. So you have to be you have to target specific things in your app. You have to identify them as cross-cutting concerns, things that apply in more than one place, and do use cautiously. You should also be we should never be afraid to change your code back. So if you move something into something like that, this doesn't only apply, of course, for traits, but if you move something somewhere in an abstraction or in some sort of piece of code and you're not happy with it afterwards, you should always change it back. There's nothing wrong with that. And there's what I call uber cross-cutting concerns. These are basically things that would apply in all your screens, or your activities specifically, not fragments, regardless. Things like session management. How long has my user been in the app? When is the app in the foreground? You might want to do other things about when your app is in the foreground, always do this thing. And when the app leaves, do this other thing. Now for those things, Android introduced a similar concept. It's called, as you can see, the application has a method called register activity callbacks. This basically takes an object that has a subset of the activity callbacks. It gets on start, on stop, on pause, resume, that sort of thing. It's a smaller subset of what our library provides, but this allows you to attach these objects and they will receive all the callbacks from all the activities in your app. So you can't do things like targeted behavior. So you wouldn't put ads and pages into this because A, you don't get a direct, because you still reuse the same object without configuration everywhere. So it's kind of like the first example I showed. It's a statically configured object that always works the same everywhere. And B, it works everywhere. You can't say, I don't want this to work in this screen. So it can be quite tricky. But if you have a use case for it, they are the preferred method. We use them as well all the time. So speaking of which, how do we use this library, the traits library at Shazam? So we use them for page views and ads, like I've demonstrated. We actually do this in our code. This is not a proof of concept. This actually came from some refactoring we had done in our code and then became a library, basically. Yes, implicit user events, like I said, we inherit context for our user events, depending on those, the page views, basically. Fab, we have a floating action button in our app that triggers the Shazam process. And it's the same everywhere. It also has the same logic. It has some events generated with it that require context, and they also use the same tricks as shown before. Like I pressed the fab, which screen was I on? That happens automatically. And yeah, if you want your fab in a fragment or an activity, you just literally annotate it with fab, and you get it. If it's in a fragment that's already in an activity that has the fab, it just literally just attaches to it. It also does some more clever things like, if the view, you can actually, in the annotation, provide an ID of the view. That's a scrollable container, a list view, a cycler view, a scroll view, that sort of thing. And it will automatically bind to its scroll listeners, depending on which class you use, and it will hide the fab automatically when you reach the bottom of the list, so that you can display the content to the user. And when you scroll up, it will automatically appear. And all that happens with one line of code. We also have a hierarchy viewer trait for debugging. This is a library that was created by Romain Guy from Android like years ago. Basically, for those of you that don't know, a hierarchy viewer is a very useful tool. It allows you to inspect the hierarchy of your view in a tree-like format. You can zoom in and out and see how long operations took, like drawing, inflating, and that sort of thing. But the problem is that it doesn't work really in production devices. You can only use it in an emulator or in Genymotion, like I have here. But if you run this piece of library that he wrote, is basically two callbacks. You have to call something in on start and something in on stop. Actually, something in on destroy as well, so 3 callbacks. And that runs a local server on your device that the hierarchy viewer can connect to. That is perfect for what this library does. You have to do something in some callbacks of an activity or fragment, this is what you use. So we have that trait, and whenever we need to use it, we annotate a class and it works. And of course, more to come, we always find new use cases for it. Speaking of which, a shameless plug here, about one of my libraries that I worked in my spare time. It's called Butterknife. Well, Aspects, I have to change the name to traits back. But to demonstrate what this does is, how many of you are aware of the Butterknife library by Jake Wharton? Everyone, of course. It's a very cool library. It basically allows you to do something like this. I don't know if the text is legible there. Let me zoom in a bit, if I can remember how to. Command plus, there you go. So it basically allows you to bind views, basically, kind of like in an automatic injection-y type thing. So you can basically say in your field, add bind view, and you can give it the ID, and it will generate a companion class that does it for you. But to do that, you have to basically call this line, Butterknife bind this. And of course, you know, as usual, you also have to set your content view, which is not a bad compromise, but you still have to do this everywhere. And in the fragments, the code is slightly different, so you always have to remember how to do it in fragments. You have to do something, you know, create view, I think. So again, this is something that you do in some specific callbacks. This is perfect for what the traits library does. There you go. We've created a custom annotation here. It's called bind layout. We extend our aspect activity, obviously. But that takes an ID. You can see there's nothing in onCreate now. This happens automatically for you. The above code runs is exactly the same, nothing fancy. We don't even have to set the content view, of course, because we've already defined it. And the good thing about this is because this is an annotation that has two traits attached to it, one for activities and one for fragments, the way it works is different between them. So you can reuse that annotation both in a fragment and in an activity, and you will get the right implementation automatically. As long as the behavior is the same, you can do this. So that's one thing. There is this repo of the example I've shown you is online in that URL. I might have to change all of these links to rename remove the word aspect and rename it with trait, but this was such a short notice I didn't get a chance to do it before this conference. But all of these will point to the new location when and if I do change them. That was it. I hope this talk was useful. I hope it gave you some ideas, food for thought. Please do check out the library. Please, if you can come up with any other cool things that might be put into a trait, let me know. Do a pull request. It would be very cool to create some sort of repository of all these really cool reusable components that people can just attach to their activities and suddenly get behavior. Yes, any questions? Very silent crowd. All
okay,
right.
I think that's it. Thank you for the great speech.
No worries. Thank you.